name. I'm going to work up to that in stages. It's going to take me 3 or 4 small steps to get to the point where the solution is obvious. It's like mathematicians, right? Half an hour's hard work proving a theorem on the board, and they say, it is therefore obvious that. So here's the first thing I'm going to do. Def hello to return the string hello. Hello, sweetie. Any Doctor Who fans? May I just say, the most recent Doctor, the twerpy kid, yeah, they should have paid the extra and got Patrick Stewart. Seriously, I don't know if you know, but he was approached and he wanted more money than they were willing to pay. Patrick Stewart as the Doctor. Yes, enough of this running around being enthusiastic. Let me straighten my tie and carry on. Sorry, they blew it. Anyway, I've got a function called hello. Okay? It returns that string. And if I say hello, and print the result, it does exactly what you expect. So far, so good? Okay. Now, let me say h equals hello. And then print a call to h. Notice here that I'm not saying h equals hello with parentheses. As soon as I put the parentheses after a function name, I'm saying call this. Here, I'm just assigning the value of the variable hello to the variable h. Because in Python, in Perl, in Ruby, and in fact, behind the scenes in languages like Java and C#, the function name is just a variable. It happens to point at a bunch of instructions instead of at an integer or a block of text or a list of numbers. When I say def hello and this, what I'm saying is go and create a function, something that's a bunch of instructions, and then assign it to the variable hello. Okay? Hello is just a variable like any other. It's just a name that points at something. Sometimes hello might point at 1, 2, 3. Other times, hello might point at the list hello and sweetie. And then in the third case, hello points at the instructions that do that. That's all it is. A function is just a variable. Okay? Sorry, a function is just a value. A function name is just a variable. Okay? So, knowing that, the fact that I can say, all right, hello is pointing at a bunch of instructions, make h point at the same instructions, is no different from saying hello points at 1, 2, 3, make h point at 1, 2, 3. Right? There's a value in memory. Currently, the variable hello is pointing at it. Okay, make the variable h point at it. Doesn't matter whether the value is a number, a list, a bunch of instructions. I can have a bunch of variables pointing at it, and then I can go to that variable and say, I want to call you. I want you to go to the thing you're pointing at and run that, because that's what the parentheses mean. Okay, so let's see whether this actually works. And yes, it does. There's the output from the call to hello. There's the output from the call to h. They are always going to be the same because they're pointing at the same instructions. Okay, you look unhappy.
Yeah, in Java or C, it wouldn't work like that, would it?
It would.
It would?
They hide it from you because... Okay, let me jump ahead. In a language like C, I have to tell you that this is a function that returns a list of integers. And I have to tell you that its input argument is 2 strings. So if I'm going to create another variable that refers to the same function, I have to have a way to say, this is a reference to a function that takes 2 strings and returns a list of integers. The syntax for that is really ugly. Okay? It's doable. It's absolutely doable. And if you take a look at advanced C programs, they do it all over the place. But it is hell's own breakfast to read. It's really hard to read. In Python, we don't have to declare types. Any variable can point at any kind of value, so it makes this kind of thing easier. All right? Syntax can make things easier or harder. True story. Most people on this side of the channel believe that Isaac Newton invented the calculus. Right? Over on the continent, they say it was a tie. Leibniz got there pretty much the same time. Right? What nobody will dispute is that it wasn't until the 1820s, 1830s that you start to find famous British mathematicians again after a long drought. Why? Because for reasons of national pride, the British stuck to Newton's notation for calculus. Leibniz's notation was a lot easier to read, to teach, to understand, to work with. It didn't get in the way. Newton's Fluxion notation was just really hard to read. Never mind typeset. There was a lot more cruft getting in the way. And it turns out that makes a huge difference. A good notation can make things easier. A bad notation can make things harder. The notation that's used in C, C++, Java, unfortunately C#, for saying, I want a variable and it's going to refer to a function that's defined elsewhere. It's this big, because of all those types. Right? In Python, a variable just points at something. I don't have to tell you what it's pointing at. It can point at different kinds of things at different times. It's a name that points at something in memory. We're done. So it makes this kind of thing easier. Okay? So, let's have another look at what I just did.
Can I just ask, when you
Please.
say point to, is it actually a pointer or is it a copy of it?
It points to the same thing in memory.
Okay, so if you
Okay,
change
it
it
doesn't-
below,
If I could actually reach inside that set of instructions and change them in place, then I would see the change show up in both places because they're both pointing at the same thing. Okay? That just becomes a bunch of instructions in memory. That's a variable that points at those instructions. And now this is pointing at the same instruction, so it doesn't matter whether I call it through the long name or the short name. They're now pointing at the same thing. So far, so good? Okay. I'm going to Everybody okay with this? So far, so good? Okay. And functions equals the list of hello and goodbye. What? Okay. Hello is pointing at those instructions. Goodbye is pointing at those instructions. They're values. I can put values in lists. If I say first equals 1, 2, 3, second equals 4, 5, 6, and then values equals first, second, you don't flinch. Values is now the list of 1, 2, 3, and 4, 5, 6, right? Look at those first three lines. First is 1, 2, 3, second is 4, 5, 6, and now I'm going to have those two things in a list and I'm going to assign it to values, and values is now the list 1, 2, 3, 4, 5, 6. Nothing big. Okay. Hello is a variable, points at instructions that do that. Goodbye is a variable, it points at instructions that do that, so now I'm going to put them in a list. Functions is now the list, the first element of which is the instructions that return hello sweetie, the second element of which is the the instructions that return come back soon. Okay? So I should be able to do this. Functions of 0, and then call it. Okay? Let me break that down. Temp equals functions of 0, and then call temp. Well, functions at 0 is pointing at that block of code. We're good? So I'm going to pull that out and assign it to temp. So temp is now pointing at that block of code, so now I can call it. So this should print out, hello sweetie. Let's give that a try. Oh, I have to print it, of course. Okay. So far, so good. Please.
what's the 0 list doing?
That's location 0 in the list. Functions is a list with two values. So functions of 0 is the first value, and functions subscript 1 is the second value. If I come back up to this, what is value 0? Yep. Okay. So what is function 0? Hello. Okay. It's exactly the same thing. There's no magic going on here.
Why did you have to write temp?
I didn't. I could just say print functions of 0 and then call that. Okay, syntax is looking a little bit clumsy, but read it from left to right. Functions is a list. Functions element 0 is whatever's in the first slot of the list, and now we're going to call that because that's a function. We can call functions. So go to the list, get the first function out of the list, and do whatever it tells you to do. Okay? This is exactly, if I come back to that, it's exactly like saying temp equals values of 0, print temp. Okay? If I show you this, values is 1, 2, 3, 4, 5, 6. Yes? Okay. Temp is now, right? And then print 1, 2, 3. Okay, down here, functions is that function and that function. I've just stumped them in a list. Okay. So temp is, and then I print whatever I get when I call that function. Okay?
So why do you have to have the brackets around it on the bottom?
Because here I'm saying this is a function, you need to call it. Right? Here, that's an integer. So I can just print its value. It doesn't have to go anywhere else. It doesn't have to run instructions to calculate its value. It's now holding the number 123. This is holding the instructions that give me back that string. If, for example, I change this to be hello, comma, space, plus sweetie, maybe it's a bit clearer that hello is actually doing some work. So here I have to say, okay, go to that thing and do those instructions and give me back the result. Here, temp is just an integer. Integers are really stupid. They don't know how to do anything. They're just a value. Hello, I am the number 123. That's about the extent of my abilities. Right? I don't do 123. It's not a verb, it's a noun. Down here, that's a verb and that's a verb. Okay? So I'm saying, okay, go and do that verb. That's what the parentheses mean. I mean, call that function. Okay? It doesn't require any arguments, so I don't have to pass anything into those parentheses. Okay? And if that works, then I should get the same result by printing functions of 0 and then calling that. Here, I've just assigned functions of 0 to a variable, and then I'm saying call that function. Here, that's the same thing as temp, and then I just call it directly. Okay? This starts to get clumsy because, okay, square brackets and parentheses, and there's a lot of punctuation being stitched together. Right? But it works. Everybody okay so far? Ish?